Okay, so today we're going to start section 2. Today will be the non-calculator portion. So here is a picture of the unit circle. We watched those videos last week. There's songs that'll help you memorize it. But if you look at it, there's a lot of similarities to it. So if you notice, all of the coordinates have a denominator of 2. All of the numerators have a square root, except for the ones, because they've already been square rooted. So if you notice, every numerator has a root except for ones, because they've done the square root of 1 and left behind a 1 without a radical. And then for the angle measures, they're listing them in both radians and degrees. Now, let's say you memorize the degrees, but you forget the radians. You could always convert it. You could always multiply your degrees by pi over 180 to convert them into the radian measures. But you could sing the song in your head, pi over 6, pi over 4, pi over 3, pi over 2, whatever it's going to take so you can memorize it. And then in one of the songs, it actually told you, to connect the lines. And then you can see that the denominators are the same when you connect the lines. Someone in my A period or C period, they realized that all of the angles that start out with the reference angle of 30, they all have a denominator of 6. All of the reference angles that have, or all the angles that have a reference angle of 45 have a denominator of 4. And then for the 60, they all have a denominator of 3. So a lot of similarities. It's really not that hard to memorize. So bottom line here, the whole reason why this is called a unit circle is if we refer back to these 4 ordered pairs that are on my axis, if I were to draw a segment from the center to this ordered pair, this has a unit, a length of 1, because it's 1 unit long. It doesn't matter if I draw it along the y-axis up to this point. All of these are actually radii in my circle. And if you recall back from geometry, no matter where you draw a radius in your circle, it's always going to have the same length. So when we go to make our triangles here, our hypotenuses are actually going to be our radius or our radii. And our hypotenuse now is going to have a length of 1. Whereas when we did it in the other chapter, the hypotenuse had a length of 2. So you can either draw the triangles, or if you memorize the unit circle, when we calculate our sine values, all we have to do is look at the y value of the ordered pair, and that's our answer. For cosine, we're going to be looking at the x of the ordered pair, and then that will be our answer. And we're going to see this as I go through and do all of the angles in the unit circle using a reference angle of 30. So let's go ahead and take a look here. So again, here's my unit circle. I'm going to first work with quadrant number 1. So I'm going to go ahead and calculate sine and cosine for all of the angles using a reference angle of 30. So when I want to do sine of 30, remember sine means opposite over hypotenuse, or y over r. Now, when I go to do these, my r value is going to be 1, just like we did before. My y value is going to be the y in the coordinate. So if I were to draw the triangle, though, I could do it this way also. Here's my 30 degrees. I could come down here, fastest way back to the x-axis. I can make my right triangle here. So again, this time, my right angle is right here. This is the 30 degrees. My hypotenuse is 1, because it's a radii. And then, actually, I need to make it go further out. Let me go further out here. All the way to the radius. Let's see. Let me go all the way and then come down. So this radius is 1. Over here is the right angle. Now, let me just review the relationships of the legs. 30, 60, 90. Remember, opposite the 30 is A. Opposite the 60 is whatever A is with root 3 behind it. And then your hypotenuse would be 2 times A. So in this particular problem, my hypotenuse equals 1. So this tells me my A value over here, 2A equals 1. When I divide by 2, A equals 1 over 2. And then over here, my A is 1 over 2 with root 3 behind it, which is just root 3 over 2. So what's different than before, my hypotenuse was 2. The side opposite the 30 was the 1. So don't get confused on that. So this is why if you memorize the coordinates, all of these, sine is always the y of the ordered pair and cosine will be x. So back to my 30. Here are the coordinates for the 30 degrees. So if I take my y, it's 1 over 2. My r value is always 1. Anything divided by 1 is itself. So the sine of 30 is 1/2. If you realized it, look at the y of your ordered pair. It's 1/2. If I did cosine of 30, this one is going to be adjacent over hypotenuse or x over r. So adjacent to the 30 is the 3 root 2, or root 3 over 2. And then divided by the hypotenuse, which is 1, which gives you root 3 over 2. If you'd use the ordered pair, the x of my ordered pair is the root 3 over 2. And again, the r is 1. Either way, they simplify to square root 3 over 2. Now when I move to quadrant number 2, the way that I got this 150, remember you take 180, you minus your reference angle, and that's how I came up with the 150. So for here, for sine again, you're either going to memorize it as opposite over hypotenuse or y over r. When I find the 150, which is right here, if I do 1/2 over 1, anything divided by 1, and the sine of 150 is 1/2. For cosine, this is adjacent over hypotenuse. So the side that's adjacent, if I draw my triangle in here, so this would be 1/2, this would be 1, this would be root 3 over 2, and that would be negative. So if I do adjacent to the reference angle, which is 30, adjacent is going to be negative root 3 over 2, and hypotenuse is 1. Either way, even if I said this was x over r, same thing, and it simplifies to negative root 3 over 2, which again is the x of the ordered pair. In quadrant 3, to get the 210, I'm doing 180 plus 30, and that's how I get the 210. Opposite over hypotenuse, or y over r. So if I draw my triangle here, this is here is the negative 1/2. The hypotenuse is 1, and my x value is still the same. So for sine, again, the y value, or the side opposite, is going to be -1/2, and my r value is 1. Divide that, and the answer is -1/2. For cosine, adjacent over hypotenuse, or x over r, so that would be -√3/2, divide by 1. Simplifies to -√3/2. Then the last quadrant, remember you find that by doing 360 minus the reference angle, and that's how I get the 330. So if I draw the triangle here, my hypotenuse is 1. That's 1/2, -1/2. And then over here, my x value, or across, is going to be √3/2. So opposite over hypotenuse, or y over r, gives me -1/2 over 1, which is -1/2. Cosine, adjacent over hypotenuse, or x over r, and this will be √3/2, divide by 1, or the r value of 1, which is √3/2. Notice each time sine was always the y of the ordered pair, cosine was always the x. Now, if I ask you to find cosecant or secant, for secant, we would just flip the cosine to the reciprocal. For cosecant, flip the sine. So just remember, sine and its reciprocal is cosecant, and then cosine's reciprocal is secant. Now for tangent, we got to work for that. Because if you recall, tangent is opposite over adjacent, or y over x. So to find tangent, we're dividing the y coordinate divided by the x coordinate. So let's do the sine, or not the sine, sorry, the tangent of 30. The coordinate for 30 is √3/2, comma 1/2. Remember, in an ordered pair, this is x, this is y. So to find the tangent, I'm going to do 1/2 divided by the square root of 3/2. Remember, this fraction bar means division. So I'm going to be doing 1/2 divided by 3/2, which means multiply by the reciprocal. The 2 simplify. 1/√3, rationalize, and the answer for tangent of 30 is √3/3. If it were cotangent, I would flip it. Now, remember, this whole chapter is in radians, so I'm not going to ask you to find sine, cosine, tangent of 30 degrees. I would instead ask you to give me the sine of pi/3, or pi/4, or pi/6. I'm going to give you the degrees, or the angle measure in radians now. So this slide just has a review. So anytime we're using the unit circle, if I ask you to find sine of any angle measure that's on your unit circle, look at the y coordinates. If I ask you for cosine, you look at the x of the ordered pair. Tangent we have to work for. We're going to divide the y by x. And then again, make sure you know the associated reciprocals. This is just a screenshot from the textbook, this part of it, and then this is just what I've handwritten. So they both say the same thing. So let's try and practice this. So here's my unit circle. When you're given a question and they ask you to find the sine of whatever it is, look for that angle measure on your unit circle. So everyone try to locate 3π/2 on your circle. Did you guys find it? Okay, notice it's right here. So when I ask you to find sine of 3 pi over 2, what are we going to look at? The y. And the ordered pair that's associated with the 270 or the 3 pi over 2, this is a quadrant angle. So I'm going to use, my answer is going to be, I'm using y, so it's -1. So the y is the second number and the x is the first. So when I say to find cosine of 3 pi over 2, what do we get? What do we look at? We look at x and it's 0. Good. Tangent, what do I use? Y divided by x, or -1 over 0. Undefined. Nice. Now, let's say that you blank out and you're like, I have no idea where 3 pi over 2 is. You could always convert it to degrees to give you a ballpark figure of what quadrant to look for. You can multiply 3 pi over 2 by 180 over pi. You know, granted, you may not have time to do all those calculations, so be familiar where these angles should be located. Let's try another one. This time it wants me to find the 7 pi over 4. Now, a clue for you, the ones that have a denominator of 4, their reference angle is the 45. So 7 pi over 4, that's going to be located right here. What does cosine look at? Which letter in the order pair? X. So I'm going to look at the x, and my x is square root 2 over 2. For sine, what do we look at?
Y.
The y. And this one is -√2 over 2. Now, the next one. Do we have -5 pi over 3 on our unit circle? No, we do not. Do you guys remember about coterminal angles? It was on the quiz. How do you find an angle, a coterminal angle? What do you do? Beautiful. Okay, so to find a coterminal angle, we have to add or subtract 360. So on the quiz, I asked you to give me a positive coterminal angle. When we did the homework, I asked you to give me both positive and negative. Now, obviously, if it's a negative angle in our problem, to get something on the unit circle, we need to add 360 to get a positive. Now, we're working in radians. Now, I know it's not labeled here on my unit circle, but 360 is equivalent to 2 pi. If you forget that, remember you can take 360, convert this degree into radians by multiplying by pi over 180. I can simplify, and that's how you convert 360 into 2 pi. So let's go ahead and figure out what angle is going to be the angle that's going to show up on my unit circle. So I'm going to take -5 pi over 3, and I'm going to add 360. But again, remember, 360 in radians is 2 pi. I'm going to put a 1 in the denominator. I need to find a common denominator. My common denominator here is going to be 3. So I'm going to multiply top and bottom by 3. So this becomes 6 pi over 3. When I add fractions, I keep the denominator and add the numerators. So this becomes pi over 3. So this tells me the angle that I now need to look at on my unit circle to figure out tangent of -5 pi over 3, which I'm really doing pi over 3. So pi over 3 is located right here. Remember, tangent is y over x. So I'm going to take my y value, which is √3 over 2, and my x value, which is 1/2. I have to work for it, so I'm going to divide this, which is multiplied by the reciprocal. The 2's cancel, and I get √3. So the tangent of negative 5 pi over 3 is the square root of 3. Now, the other way I could have done this is I could have graphed this angle and see where my terminal side ended up. Now, let's say, well, I have no clue of where negative 5 pi over 3 is. I could take negative 5 pi over 3, convert this to degrees, and then I can see how I could make my circle or my swirls here. So again, to convert, you're going to multiply it by 180 over pi. And this gives me a negative 300 degree angle. So if I wanted to graph this, I would go 90, 180, 270, and then I need to go 30 more. Notice it was the same angle I got by adding 360, which was the pi over 3. It's a lot easier than having to do the conversion and then have to graph it. Just add 2 pi. Now, if it's a really large angle, and I do that next, you have to subtract 360 or 2 pi. So for example, and this one isn't in the notes, I'm going to add this one. Let's say instead I said to find the sine of 11 pi over 3. If you look at your unit circle, that's actually not there. So what I'm going to do is take 11 pi over 3 and subtract 2 pi. Again, I need a common denominator. So it's going to be 3. So 11 pi over 3 minus 6 pi over 3, which gives me 5 pi over 3. And now that's on the unit circle. So 5 pi over 3 is actually on my unit circle. So let's go ahead and locate 5 pi over 3, which is down here. Let's see, right here. And I'm doing sine, so I want the y, the y of the order pair. So the sine of 11 pi over 3 is actually negative root 3 over 2. Because sine uses y. Next. Now, before when we were looking for an angle, they called it theta. So this time when it's in radians, they're using the variable s. Generally, whenever there's a letter here, this is an angle measure we're looking for. And to determine if it's in degrees or radians, they're going to specify the interval they want you to look for it in. So when it's from 0 to 2 pi, you should know that you want your answer in radians. If it said, like in the last chapter, from 0 to 360, then you know you would leave your answer in degrees. So because it says this, they're looking for our answer to be in radians. So I need to use my all students take calculus. So I've already got it labeled here. Notice my problem has cosine being negative. So I'm going to cross off the 2 quadrants where cosine is positive, because I don't want those answers. Now, cosine looks at what? Okay, I'm going to look at quadrant 2 and quadrant 3. Which part of the order pair am I looking at for cosine?
X.
I'm looking at the x. So I need to find where x equals negative 1/2 in quadrant 2 and in quadrant 3. So x equals 1/2 right here and right here. So my 2 answers are 2 pi over 3 and 4 pi over 3. Now notice my interval up here. Notice the symbols around it. It's got a bracket on the left and a parentheses on the right. So what this means is the answer can include 0, but it's going to stop at 360 but not include 360. So on the test, it had 2 brackets around it. So technically on the test, it shouldn't have included 360. However, that was a typo. So normally when you see questions like this on the test, it should have looked like this. And 360 should not been a choice. Okay, so here 2 pi is not going to be one of the angle measures we're looking for. We would exclude that because of the parentheses. Yes?
Is there any way to solve it without the unit circle?
You could draw a triangle. Also do is if you don't want to use the unit circle, remember we drew the two triangles, 30, 60, 30, 60. So for this, we know the hypotenuse is the 1, the side opposite's the 1/2, and then the side opposite is the root 3/2. So you could set up your triangles, and then you have to decide, is my reference angle going to be the 30 or is it going to be the 60? So based off the 30, this is opposite, this is adjacent, and this is hypotenuse. But based off the 60, this is opposite, adjacent, and hypotenuse. So if you didn't use the unit circle, then I needed to figure out which one would give me 1/2. So is it cosine of 30? And then from there, cosine is going to be adjacent over hypotenuse, which isn't going to be my answer. But then if I did cosine 60, if I did cosine 60, that would be 1/2 over 1, which equals 1/2, which is what I started with. But then the negative sign, I do my all students take calculus to figure out which ones to get rid of. So I know my reference angle would be 60. So then from there, I would find all the radian measures that go with 60. Does that make sense? So one thing you can do is memorize that 60, this one, all the reference angles that go with that have a denominator of 6. So it's going to be these. And then just figure out where cosine can't be negative. So then here are your 2 answers. You can do it that way, I guess. Or actually, no, it was negative. So I eliminate, let's see. So I'm looking at the 6, sorry. Let's see, let me erase this. All right, so for the 60, it's got the denominator of a 3. So I'm looking at all of these as the possible answers. But again, cosine was negative. It was a -1/2. So I get rid of this, and I get rid of this. So my 2 answers are 2 pi over 3 and 4 pi over 3. So that's how you could do it without the unit circle. You could actually go back to drawing the triangles. And let's see the next one. Number 2. It's a lot easier if you memorize the unit circle. Sine looks at y. So I'm going to be looking for a y value that equals -1/2. Okay, again, sine is negative. So this tells me I need to get rid of the positive quadrants, which are those 2. All students take calculus. So I'm looking where the y value is a -1/2. So I can see that it's here. And I can see that it's here. So my 2 answers are 7 pi over 6 and 11 pi over 6. And then the last one, cosine. We're looking at, so we're going to, oh no, there's 2 more. So for cosine, we look at x. Again, I want cosine. I want the quadrants where cosine is positive. So let me erase. So cosine is positive here and here, so get rid of these two. And then I'm looking for an x value, that's root 3 over 2. So I'm looking for this. So root 3 over 2 is going to be 11 pi over 6 and pi over 6. Notice the denominators are the same when I'm doing these problems. So this answer is pi over 6 and 11 pi over 6. For this next one, back when we did chapter 5, I told you to memorize that the tangent of 45 was 1. Now, we could still do this because remember, tangent is y over x. So in order to get a 1, I'm looking for which order pairs have both my x and y with the same number. And you can see that that's going to be the root 2 over 2 because those are the only coordinates that have the same thing. So if I go to my unit circle, erase this again. I want tangent to be positive. All students take calculus. So I'm getting rid of this one and this one. And I'm looking to see, here's my 45. So as soon as you see it's a 45-degree reference angle, I'm looking for the one that has the denominator of 4. But if you think about it, this order pair, root 2 and root 2, anything divided by itself equals 1. So whenever you see tangent or cotangent equaling 1, you should realize your reference angle is 45. Because the only way to get a 1 is to divide those. You may think it's coming from one of the quadrant angles, but it will help you tremendously if you memorize this fact. Okay? Also remember the radian equivalent is pi over 4. So this actually is root 2 over 2 divided by root 2 over 2, which equals 1. So we were looking for quadrant 1 and quadrant 3. So the answers here, S equals pi over 4 and 5 pi over 4. So the homework listed on the next slide is due on Wednesday. You should be able to get probably up to, let me take a look here. So what I've covered today in the notes are 7 through 21, and then 23 through 33. This will be with your calculator, and I'm going to teach you this tomorrow. So if you don't want to wait and do all of this tomorrow night, you could at least get started on this, and you just use the unit circle. Or again, you can draw your triangles. Just remember that the hypotenuse in the triangle is going to be 1.